Hi, welcome to section 9.4, Geometry's Most Elegant Theorem. Our objective is to apply the Pythagorean's theorem and its converse. And for homework, we'll be working on page 387, 1 to 29 odds, 33 and 34. So Pythagorean's theorem. The square of the measure of the hypotenuse of a right triangle is equal to the sum of the square of the measures of the legs. Or as most of us already know, a squared plus b squared equals c squared, where a and b are the legs and c is always the hypotenuse. So our first theorem, if the square of the measure of one side of a triangle equals the sum of the square of the measures of the other two sides, then the angle opposite the longest side is a right angle. So this is one of the applications of Pythagorean's theorem. It helps us to determine if a triangle is a right triangle. So let's take a peek. So looking at our triangle here, we see that we have our longest side right here, which is 10. What we're going to do is we're going to apply it to Pythagorean's theorem. 6 squared plus 8 squared equals 10 squared. So we're going to try and see if Pythagorean's theorem works. And if it does, it means we have a right triangle. Now, the hypotenuse should always be the longest side because it's always opposite the biggest angle. So let's see if it works. 36 plus 64 equals 100. Is that true? Absolutely. Which means that the right angle is going to be opposite the biggest side, so it would be formed right there. So this brings us to our extensions. If a squared plus b squared equals c squared, then we have a right triangle. Our second one, if a squared plus b squared ends up being less than the c squared, then we have an obtuse triangle. And last but not least, if a squared plus b squared is greater than c squared, then we're going to have an acute triangle. Now I know it seems kind of backwards. Less than means obtuse, greater than means acute. If you can remember that it's backwards, that's great. Here's what I always think of it as. I always look at the c squared, and I say if the c squared is just perfect, it's just right, forming a right triangle. If the c squared is too big to be equal, it's obtuse. And if the c squared is too little to be equal, it's acute. And that's how I remember it. So here we go. All of our triangles are right triangles. We're going to solve for x. So here's my right angle. The only part of Pythagorean's theorem that matters is your c. Your c has to be your hypotenuse, which is across from your right angle. So here we go. Let's plug it in. 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared, which means 169 equals c squared. Get c by itself by square rooting, and our c is 13. For our second one, our c is going to be our hypotenuse, which is going to be 5, which means that we can either call a our x or b our x. It doesn't make a difference, but here we go. X squared plus 4 squared equals 5 squared, where 5 is the length of the segment of our hypotenuse. X squared plus 16 equals 25. Subtract our 16 to both sides. X squared equals 9, and square root it. Our x is equal to 3. Our third one. Why don't you press pause and see what you come up with for x for our third one, and x for our fourth one. So here we go. Here's what I got. I got 5 squared plus x squared equals 10 squared. So 25 plus x squared equals 100. Subtract your 25 from both sides, and x squared equals 75. I square root it, but it's not perfect. It simplifies to give me 5 square root 3. The biggest perfect square that divided evenly into 75 was 25. And for my last one, I had 9 squared plus 15 squared equals x squared, where x is my hypotenuse. So 81 plus 225 equals x squared. Combine our like terms, and that's going to end up giving us 306 equals x squared. We're going to have to square root that. And the biggest perfect square that divides into 306 is going to be 9. It's 9 times 34. x ends up being 3 square root 34. Okay, so now we're into our word problems. We have Abby drove 3 miles north, then 4 miles east, then 5 miles north, then 6 miles east. How far is Abby from her starting point? Well, let's draw it out. Here's our starting point. She drove 3 miles north, then 4 miles east, then 5 miles north, and 6 miles east. They're asking for the direct distance. How far is she? Well, let's redraw this. How far total north did she have to drive? Let's add it up. 3 plus 5 gives us 8. And how far east did she have to go? 4 and then 6. So that gave us 10 miles east. So what we're looking for here is the hypotenuse, the shortest distance between 2 points. Let's plug it into Pythagorean's theorem. 8 squared plus 10 squared equals x squared. 64 plus 100 equals x squared. 164 equals x squared. And let's go ahead and square root it and look for the biggest perfect squares. It's going to be 4 times 41. Square root of 4 is 2, so 2 root 41 is the distance from her starting point. Our second one, find the perimeter of a rhombus with diagonals 6 and 10. So let's go ahead and let's draw out a rhombus. So it kind of looks like a diamond. And let's draw in our diagonals. Now, we got to remember back to rhombuses and some of their properties. First thing that we know about the diagonals of a rhombus is that they're perpendicular. So that's important. We're going to have right triangles. Second thing, the diagonals bisect each other. So it's going to split it into 3 and 3, 5 and 5. Now to find the perimeter here, we're looking for x. And we know that all the diagonals are bisected. All the sides are congruent though. So once we know one side, we know all 4 sides. Let's plug it in. 3 squared plus 5 squared equals x squared because x is our hypotenuse. 9 plus 25 equals x squared. 34 equals x squared, and let's square root it. There are no perfect square roots that divide evenly into 34. So x is the square root of 34. Now we want to find out what the perimeter is, so we're adding them up. Square root of 34 plus the square root of 34 plus the square root of 34 plus the square root of 34, or 4 times the square root of 34. That gives me 4 square root 34. We add those imaginary ones on the outside, but leave the inside the same. Or it's like saying 4 times the square root of 34, where outsides times outsides and insides times insides. And that's our solution. Our perimeter is 4 root 34. So why don't you try this one? Find the altitude of an isosceles trapezoid whose sides have lengths 10, 30, 10, and 20. Press pause and let's see what you can do. So here we go. I have my isosceles trapezoid. So I know if it's isosceles, those legs are going to have to match. So those would be my pair of 10s. I'm going to put my 20 up top and my 30 down below. Now, we're looking for the altitude. So here's what I'm going to do. I'm going to drop an altitude down. That's what I'm looking for. Not real easy because I don't know what this piece is. So let's do it on this side as well. We know our altitudes are going to be exactly the same. It's the distance between the bases. So what do I have formed in here? Hopefully you said a rectangle. Opposite sides are congruent. Now, if I used up 20 so far and it's isosceles, I have 10 left over to be split up 5 and 5 on each side. So let's go ahead and Pythagorean theorem. X squared plus 5 squared equals 10 squared, because 10 is my hypotenuse across from my right angle. X squared plus 25 equals 100. Subtract my 25. X squared equals 75. Square root it and simplify it. 25 times 3. So x is equal to 5 square root 3. That's going to be my altitude. So now we want to classify each triangle based on the side lengths. So what we're looking to use is that extension of Pythagorean's theorem that we talked about a little earlier. So here we go. First thing you want to do is find your biggest side. In this case, it's the 15, and plug it into Pythagorean's theorem and see if it works. Is 9 squared plus 12 squared equal to 15 squared? So is 81 plus 144 equal to 225? It is. It works out perfectly. It's just right, making this a right triangle. So for the second one, again, let's go ahead. Find my biggest side, it's 7, and let's plug it in. Is 3 squared plus 5 squared equal to 7 squared? Let's check it out. Is 9 plus 25 equal to 49? No, this gives me 34, and 34 is definitely not equal to 49, it's less than. My c squared was too big, which made this triangle obtuse. So let's go ahead and do the next one. Now, there's two side lengths of 8, which are my biggest sides. I'm just going to circle one of them and allow it to be my c. Go ahead, see what you get. I'm going to do it silently, just in case you didn't figure it out. Okay, so here we go. 8 squared plus 5 squared, is that equal to 8 squared? Hopefully, as soon as you wrote that down, you knew the answer to that was going to be no. 64 plus 25 is definitely not equal to 64. 89 is too big. Or, the way we can look at that is that c squared was just too small to be equal, making this thing acute. You try those last three. See what you can get. Just FYI, this last one, really, really tricky. So be careful. So for that fourth one, 2 squared plus 3 squared, is it equal to 4 squared? Is 4 plus 9 equal to 16? Absolutely not. 13 is less than 16. My c squared is too big. It's obtuse. 19 is my biggest side. Let's plug it in. 12 squared plus 17 squared equals 19 squared. 12 squared is 144. 17 squared is 289. And 19 squared is equal to 361. Let's go ahead and let's add that up. 433 is definitely not equal to 361, it's bigger. My c squared was too small to be equal, making this thing acute. And last but not least, 2 squared plus 3 squared equals 7 squared. I'm going to stop us dead in our tracks before we even get going. This doesn't even form a triangle. Way back in semester 1, we talked about what the segment lengths needed to be in order to form a triangle. That when you add the two smaller sides, it has to be bigger than the third side. So this isn't even a triangle at all. Not possible with those side lengths. So that was a trick question, I know. Last but not least, we have our homework answers. Homework was 1 through 29 the odds, and 33 to 34. If you have any questions, make sure you bring them with to class tomorrow. And as always, have a good one.